Good morning, everybody. So this is our next lesson on what we say how to use the law of sines. So we begin with the question here. We see we have our triangle from before, from area triangle ABC, and you'll notice that the lowercase letters represent the sides opposite of the angles. And so we see here in this case that we want to find out the area of this triangle in three different ways. And so if you remember the area triangle formula, we talked about how it was the 1/2 times the product of two sides and times the sine of the angle included. So for this situation, we would see in this case that we can express the area as 1/2 AB sine of C. We use letter K because this way I'm not going to confuse it with A as area because we're using the letter A for angle. The second area way of stripes is going to be with the two other sides of AB. Let's use BC. So that would be the same as 1/2 BC, and the angle between BC is angle A, so that would be sine of A. And so that's also equal to the same area because it's the same triangle. And the third way we mentioned before from our notes was that if we focusing on angle B and the sides A and C, we would have 1/2 AC sine of B. And so they're all equal to each other, right? That's the funny thing about this. So let's take a look now. Let's set them all equal to each other and look something like this. So K equals 1/2 BC sine A, 1/2 AC sine B, and 1/2 AB sine C. So they're all equal to each other because it's the same triangle and they should have the same area. So now I'll pose a question here. We notice that there's something they all have in common. And we'll see in this case, yeah, if you figure it out, they all have a half. So let's kind of take care of that. And then there's also that they have some letters in common too. Like two of them will have A's and two of them will have B's and two of them have C's. So now let's examine if we divide these areas by 1/2 ABC, what will we end up with? And so let's now take a look. Let's divide each of them by the same exact value of 1/2 A times B times C. Now, I want you to follow along. If you're writing this out in notes, you should be writing out notes and trying the same thing. At this time, if you want to pause and see what happens, just to try out and figure it out yourself, do so. So take a second. Okay, and so we see in this case we're dividing things out. And so the 1/2's definitely divide out. We were hoping for that. But in each one, different letters will divide out. For example, in the first one, we have BC sine A over ABC. So we see that BC divides out on top with the BC on the bottom. And the AC on top of the middle one divides A times C on the bottom. And the last one, AB divides out with AB. Now, what are we left with? Well, we're left with, in this situation, no longer the area, of course, because it's because they no longer have the elements of the area, but we do have the sine of A over A equals the sine of B over B equals the sine of C over C. Now, considering that they all were equal to each other and we divide everything by the same exact values, almost like using the division postulate, that we divide everything by equal quantities, the results should be equal to each other. So what does this mean? Well, this means that if I take the sine of angle A and divide by the side opposite it, A, it should equal to the same exact quantity as the sine of angle B over the side opposite, which you call lowercase b, and is equal to the sine of angle C, which is divided by the side opposite of it, lowercase c. Now, this kind of helps us out now because we have a certain relationship between all the sides angles of a triangle, not any right triangle, any triangle. And so now we see in this case, we have something called, this is called the law of sines. And it states in triangle ABC, the sine of A over A equals the sine of B over B equals sine of C over C. And the capital A represent the angle measures, and the lowercase a or lowercase letters represent the sides opposite of the angles. So if we know two angles and a side opposite one of the angles in a triangle, we can use the law of sines to find the other sides. This is a big rule, big law, because we can now find any information given three pieces of the triangle if we know two angles and a side opposite of one of the angles. So it's kind of like an angle side situation. We can figure out the other parts of the triangle. So kind of like angle side, and you'll see we also can use different things as well too besides angle side. So we want to look at it from that point of view. All right. So let's begin with a problem. But first, make sure you copy notes. All right. Okay. Here we go. Our first problem. And so we have triangle RST. If the measure angle S equals 40 degrees and the measure angle R is 60 degrees and RT, the measure side RT, is equal to 20, I want you to find the two other sides ST and RS. It would help definitely if we drew a diagram. Okay, so let me draw a diagram here. So let's see now, draw a diagram. And let's see, let's make this one angle R. And this one's angle S, and this angle T. And we know in this case, the measure of angle S is 40 degrees. And the measure angle R is 60 degrees. And in this case, the RT is 20. Okay. Well, we take a look, we want to find ST and RS. So the first thing we want to do is, can we use law of sines? And we want to find out the key thing for law of sines is if you know an angle measure triangle and the side opposite, so they're opposite mirror facing each other. So if we know, and we have this situation where I have an angle measure and the measure side opposite, we can use law of sines. So here, this would be considered lowercase s, this would be considered lowercase t, and this is considered lowercase r. So ST is going to be the measure of a side opposite angle R. We will use the sine of S over S equals the sine of R over R. Okay, we'll do again. Two pairs at a time, and then we'll solve for the measure of SR, RS, in this case, lowercase t. So we're going to now fill in the information here. So sine of 40 degrees. So sine of 40 is a real number over 20 is equal to the sine of R, which we do not know. Actually, we do know sine of 60 degrees, sorry, sine of 60 degrees. Over unknown value of R. And like we normally do, we're going to cross multiply. So we're going to cross multiply. So in this situation, let's give ourselves a little more space here. And so we cross multiply, we're going to get here, we're going to get R sine of 40 is equal to 20 sine of 60. Now, a reminder in this situation that degrees, of course, little degrees. My hand. Sorry, I'm using my finger because my pen didn't work out so great, so I ordered a new one. So we know that sine of 40 and sine of 60 are actual real numbers. And so we will leave them in this form because if I want to find R by itself, I can just divide both sides by the sine of 40 degrees. Divide by the sine of 40 degrees. So the sine of 40 is defined out, and so now with your calculators, please make sure you are in radian mode. Sorry, degree mode. Ugh. Make sure you're not in the radian mode. That's the key thing. Make sure you're not in radian mode. You should be in degree mode. And so you're going to do the following. Type in the 20 times sine of 60 divided by sine of 40. Okay, so 20 times sine of 60, and then divide that by a sine of 40. And this result should give you R should equal to the nearest tenth. I have 26.9. Now, I know I didn't tell you what to round off to. If you round to the nearest whole number, it'd be 27, but I got R equal to 26.9. So now, again, whenever we do problems, we want to ask ourselves, does the answer make sense? Well, let's take a look. We know in this case that the angle measure of 60 is greater than 40. Therefore, it makes sense that we are going to have a measure of the side bigger than 20, because the larger angle is opposite the larger side and the smaller angle is opposite the smaller side. So hopefully that makes sense. Okay. All right. So now, if you got like an answer of like 5,000, that would be a little extreme. I don't think that's going to happen because that's a little too big though. All right. So let's put 26.9 into our space here. 26.9. Now, we want to find RS. So let's clear the board a little bit. And so let's see now. So we got to erase this part here, erase this stuff here and all. Okay, give us some space. Okay. All right. So now, here we're looking for a t. So instead of using R, we're going to use t. Now we know the information about the sign of s and s, so we'll leave that constant. So instead of using sign of r over r, which is approximation, I recommend we use always given information. So it'll be the sine of t over t. And so let's now set up our equation. Very similar to before. We're going to have the sine of 40 over 20 is equal to, now, oh wait, we didn't solve for angle t, but we know what angle t is. So we know, what's like, what are you talking about, you know, how you get angle t. We know there are 180 degrees in a triangle. So 180 minus 60 minus 40 should give us a measure of 80 degrees. And that's going to be the remaining angle, because in the triangle, some of the angles 180 degrees. So therefore, we're going to use 80 degrees here. So the sine of 80 over the unknown value of t. Now we can make a prediction based upon what we did before. We saw that angle R had a larger value than angle S, which is 60 greater than 40. Angle T is even greater than either one of those two. So we're going to make a prediction that the measure of side T will be greater than both 20 and 26.9 because it is the biggest angle. The side opposite should be the biggest side. So we're going to cross multiply. Same as before. T times the sine of 40 degrees equals 20 times the sine of 80 degrees. And we divide both sides by the sine of 40. Remember again that sine of 80, sine of 40, these are real numbers. We do not need to put the decimals in. I'd rather you didn't, because in this case that you're going to get a rounding error somewhere. So these are considered exact values. So now we're going to find this out. We'll do 20 times sine of 80. All right, so on your calculators, type in 20 times sine of 80, all right, and then divide that by the sine of 40. You can type the whole thing in exactly the way it is, and I'm going to show that to you in a minute, though. Just want to make sure, because I got, in this case, t is equal to 30.6. 30.6, actually 30.6417777, blah, blah, blah. All right, so round up 30.6. And it makes sense again because it's larger than the two other sides. Okay, so the idea now is that we are going to put this here. And so we now can have found that this is equal to 30.6. So we found the sides of a triangle using this new rule called law of sines. Okay, so any questions out here? All right, this is okay.